we will continue the discussion. Yesterday I have posted this class note just for the reference, right? And this is the usual practice we will have during the semester. I will be posting these classroom notes because during the classroom also we are discussing based on these notes, based on these concepts, right? So they will provide some sort of recall points to you. You will be able to recall any day, like these are the things which we have discussed. But don't consider them as a kind of notes from my side. Like in the examination, when we will be having some questions related to these topics, don't try to use them to answer to or respond to these questions, right? That will be the bad practice. So these notes are just for reference purpose, so that you can recall the question topics, recall the concepts which we discuss. And because in the beginning classes, beginning lectures, we will be having discussion on these theoretical concepts, right? Maybe in between we will take some block diagrams to discuss the different elements of the IR system or search system. And after a few classes, we will be taking or we will be talking about some of the algorithms, right? So these notes are just to refer the points, just to recall or connect these concepts related to your syllabus, right? Nothing beyond it. So you can take them as a reference notes. That's what we are doing also in the previous semester. But one of the key observation we have, that is students often use the concepts discussed in these notes as an answer, right? So whenever we have some questions in the examination, they used to take out the statements and things from there and just paste them. So that's bad part because with the current setting, it is obviously feasible that we will be having basically your examination at least for mid semester 1 in online mode or online manner. So don't keep these things into your mind, right? So that's it. And I hope you are getting or connecting to these points which we have discussed, because this is how we start discussing these concepts, because IR is something which is related to the research domain also, right? This retrieval and web search or search process is related to many research domains, at least for data science and information science domain. So whenever you are dealing with information and data, retrieval or search or maybe different mechanisms of that system will be used there, right? So that's why we are getting into these details, these fundamental details, basic details, right? So till now we have talked about a few basics, elementary concepts. I'm saying elementary, right? Because these will be used, these concepts can be used on a different domains related to data science and information science. So today we will try to understand what is the internal aspect of a search process, right? So when we go for a searching kind of behavior, searching kind of mechanism, what is the internals are operating like, right? So when we say internals, means there is the position of user also, because user is basically part of the search process. He is basically the main actor, key entity for this search process. So by keeping all these elements into the discussion, we will basically review this entire process, search process. So inside we have search process, right? That's what we the first focus of today's discussion. And the second discussion is related to the different search behaviors, right? So because we have discussed in the last class that why we are conducting search at all, right? That's what we have discussed, and how it is being conducted traditionally. So on the regular basis also, we conduct our searches maybe on the search system, maybe on any platform. In most of the cases, it is on the ad hoc kind of arrangement. We are not having any structured or organized or web formatted query, and we do not have any anticipation on the possible result of that particular query. So this is the traditional setup actually, and this is how we are conducting queries or interactions with the search system for our daily information or data need, right? So now after this, if you see carefully, I mean, there are two extremes actually. So if you, we will be talking about the different search behaviors also. Like one of the search behavior we have taken as a generic, it is ad hoc. You are going to, for a given particular task, you are going to the search system and start searching about certain hypothesis, certain question, or certain knowledge need, something like that, right? So that is ad hoc. But there are various well-defined behaviors. There are various well-defined or so-called structured behavior of search. So we will discuss immediately this, and after that we will talk about the inside view of the search process, right? So now there are two extremes of search behaviors. So there are many search behaviors, but there are two extremes. Naturally, if we have range of alternatives, range of options to be there, there must be two extremes, right? So one extreme is basically a kind of lookup search, basically, which we are referring as a fact-based search also. So the first type of search behavior or search strategy is referred as a lookup search, right? Which says, uh, suppose you are looking for the phone numbers of a hotel in a city, right? So in this case, you are also somewhat familiar, somewhat informed or aware about the possible results. Like if you go into the Google and search, I need phone numbers of hotel at Delhi. So naturally, you will be getting, you will be expecting at least the list of hotels, right, in the very first go at Delhi, right? So this is what we are assuming as a lookup search. So in the lookup search scenario, the obvious situation is you will be familiar with the query, obviously, and you will be also certain or aware, or maybe some sort of idea or some sort of intuition that these will be the expected result in the next set, or maybe after this submission of query, right? So all those situations we are referring them as a lookup search, where query as well as the expected result, immediately expected results are basically somewhat familiar to the user, or maybe aware, user is aware of about that, both aspect of a search task, right? So those cases are referred as a lookup, because you are looking for a fact, looking for a result which is basically quite known to you, quite aware, quite familiar to you, right? So that's why it is called focus search. Also, it is referred as a focus search in theoretical domain, and it has these two properties. It will have a specific goal, and it will have expected result with the user knowledge space, right? That's the two properties which lookup search will have, right? So a specific goal means you will have these list of hotels, list of shops where you can get medical facilities, something like that. But there is another extreme where both ends are unknown, right? And those scenarios are referred as exploratory search, right? Exploratory search refers referred as an open-ended search. And why we are saying is open-ended? It means in the beginning itself and at the start itself, user is not having any idea about the possible query term, right? So whatever task user or individual is having, he is not having any idea how to write, what to write into the search system to start the search, right? So you can estimate at this point what will be the level of vagueness in the query. I mean, if user somehow typed a query, maybe a keyword, maybe a sentence, maybe a paragraph also, you can assume, you can have an idea that what will be the possible level of vagueness, possible level of uncertainty, possible level of ill query, ill formatted query, right? That's one in. Second in, user is not having any idea how to utilize the first set of result, because he is not having any idea about the possible results, their meanings, their purposes with respect to the initial query, with respect to his current needs. These are the two different aspects, right? We will be getting into it, because in a search task, query term and his real needs both are different, right? You cannot say that whatever query I have typed, it is it is entirely capturing your information needs, right? There is the gap. So we will be talking about it. There are various systems available which are trying to capture these two aspects of a search task, right? So in the case of exploratory based search, you do not have clear view clarity on the possible search results, search goals. Goals means the eventual milestone which you are trying to achieve, which you are trying to get into. You are not having any idea that after these many things, after these many results, I will be there, and that will be my end point. It is very difficult in this case particularly, right? Similarly, you do not have any idea about the possible result correlation with your query, with your needs, right? So there are various situations where we assume that exploratory search is the phenomena which is existing, right? So if I give you a task and provide you the you can say the data set of any satellite which is capturing the uh, details about the possible country, some sort of spectral images, and I suppose I give you a task that, okay, can you find out this hypothesis, or can you validate this hypothesis? So if you're not having any awareness on the data attribute or facets, it will be impossible to you that how to start the search on the database, right? So this is kind of situation. So if you take one of the citizen of a country and ask, okay, can you go to the Google search system? This system will help you. Can you start searching? Can you start searching for a question? And question is like, can you tell me the reasons of COVID? What is COVID? Something like that. So if you give a hypothetical question to a person who is not known to that domain, for him it will be most of the difficult question to reach to answer, right? So there are many situations realistically and real world and daily life where we are also feeling helpless, and it is equivalent to a situation. Suppose you are basically natively belong to North Indian part, and suppose for certain deputation or certain appointment, or maybe something job related, you have been shifted to the southern part of India. Now, to a new city, like if you're roaming into Chennai or maybe any other city, and you are basically from the North Indian part, and in the southern part you're not aware of the language. I mean, from by which you can communicate, right? And suppose you are trying to purchase certain things which are belonging to the local area, like you may be looking for some of the ingredients which could be helpful for preparing sambar or anything. So if you go to the local area, local shop, and you're not about which side that shop is, so that is kind of exploration behavior. You are not aware of the starting point, right? You are not sure about where you will be finding the good result or good shops or good ingredients, right? So you are unaware of each and every element, but there is a task at your hand. So how to start in this situation? So exploration or maybe conversation or maybe interaction could be helpful in this situation, right? And that's what the solution is. So now these are the two extremes which we are talking about. Exploratory search or data exploration is one of the dominant research domain which is picking up, because this is what it is closely related to human tendencies also, right? So in the society, we are learning a lot of things by having simply conversation, and conversation or conversations among individuals is the one of the prime example which is related to exploratory research, because in the exploratory search or in the exploratory behavior, we tries to gain lot of knowledge by having informal discussion between two individuals, right? So if you are unfamiliar to an individual, you start interacting with him, maybe by having some discussion on some common points like sports, politics, something like that. So that's how we are basically also engaging or having discussion in the real life also. So that's what it is assumed that whenever you are having this situation, this kind of behavior, you should develop some software or some system, some such system which can provide some mechanism to have interaction with the system, right? There should be no structured form of query. It should be informal, right? Like one of the prominent example is question answer based mechanisms, like you can get into the format of Quora. Quora is one of the example where we can get few related answers for your initial questions, right? Though that requires also some sort of statement writing approach, right? So by keeping these two extremes, if we see, I mean, there is a specific note which says in the case of exploratory search, you need to have some extensive cognitive effort. So because I'm saying, if you are trying to engage with an individual for interaction, you need to have some sort of ability like grasping the whatever response we are getting, so grasping the responses, processing the responses of the system of maybe of the individual. And in the case of lookup search, you need to have some expertise, basically, right? That's what it is expected. So both ends are having some limitation that we have to observe. Now, by keeping these two search behaviors into two extremes, if you see the ranges of behaviors, I hope this is visible, perfectly visible, or do I need to zoom it little more? Yeah. Now, yes, let me try partially. Yeah. Yes, say it carefully. So in this case, you can see or you can spot, like we have four broad brackets, you can see, or four broad categories of such behaviors. So you can read and you can have your own answer also, that okay, this behavior is missing. So you can read here in the bottom where we are saying known knowns. Known means your query formulation or initial query is known to the user, and possible relation with or possible or expected result is also known to the user. So if you place such behaviors into this bracket, the behaviors like lookup search, that is primarily is the starting point basically. Then we could have fact verification. Suppose you are trying to verify like what is the $100 today, something like that. So it is a verification. So conversion is there. Naturally, there is a conversion formula available. So you can get it for temperature verification, you can get for currency conversion, you can get for temperature, maybe weather, maybe there are the. So you are getting it verified. Your fact, whichever fact you have, you are getting it for fact verification. Now there is some information search also. You can look for the possible list of hotels. You can look for the possible list of routes, or maybe a distance, maybe different features, something like that, right? Fact finding is also there. Simple search is also there. So all the behaviors where query as well as the expected result or maybe relation with query is known to the user. User is familiar with that part. You can keep all these behavior in the very first quadrant, right? Similarly, if you question the query part, or maybe question the this second in part, which is familiarity with the or awareness with the results, possible results. So if you go upward, where we are saying unknown knowns, it says your query is not known, or query is not that certain with the user, but results are somehow expected, right? And that's what we are saying as a question answering system are also falling into this bracket. Then we have known item search. Then it is like having something onto the e-retail platforms, right? You start with some item, though you are not precisely familiar with the object, but you can start exploring towards the object. You are familiar with the possible. In this case particular, you are partially or maybe aware about the possible results, but maybe not sure about the initial query. Partially sure about the query basically. So it is like inspection, review, examination, or a specific search, right? But if you open this result part also, it will become like known unknowns, right? So there we can have different behaviors like investigation, refinding, synthesizing, comprehension, analytical search, transactional search also, evaluation, and comparison. So there are many behaviors, many learning kind of behaviors available here, where you need to have some sort of idea, some sort of seeking process involved, right? So when we have this open end, maybe uncertain end at the result side, then we need some sort of seeking element. Yesterday we have mentioned that searching is a one behavior, and if you add learning part into the search behavior or with search behavior, it will become seeking, right? And if you are not sure about the possible result and its relation with query, you need to start learning. You need to learn something. You need to gain something. and for that we need to provide something on the search system or maybe search process. So that's one quadrant, and the last quadrant, which is having this extreme things like exploratory search, where we are saying both ints are unknown, right? You're not sure about the precise query, accurate query, or relevant query, and you are not sure about the possible relation of your query and possible expected results. Both hints are unknown. So here you can say we have placed different behaviors like discovery. Browsing is also one in. Exploratory search is already there. Then there is a field which is nowadays picking up. It is called explanatory search. Then we have navigational search, right? So these are the few behaviors which we have observed actually, because from the last 8 or 9 years we are in the process of observing the different literatures available, different works are available, which are partially highlighting these search behaviors, right? So in the domain of at least information science, I am saying this information science, not data science. In the domain of information science, these are the behaviors available for which various systems, various websites, various platforms has been designed, right? And if you observe their internal, theoretical internal or maybe their properties, you can place them in these 4 brackets based on only these 2 parameters. 2-dimensional classification you can say, or 2-dimensional clustering you can say, whatever you say. So it is basically falling into these 4 quadrants or these 4 brackets, right? Now with this, this is important to understand, because in future some of you might be working upon some image processing kind of thing, some sort of where this nature of searching, nature of retrieval, or nature of search, nature of matching is involved. So matching is also kind of such behavior. So you need to see which side I should focus upon. So if you are talking about designing a system for question answering, you should know in the beginning itself that user will be submitting some unsure, unaware, or ill-phrased questions. So you should have a mechanism in your system to precisely process the query part, right? You should not worry about the possible presentation of the result, because user is having some idea about the results, right? Similarly, if you are trying to get into a system design which provides browsing, and browsing means both things will be unknown to the user, so you should have some interface where you can provide some controlling features on the GUI, maybe interface, through which user can navigate without entering a query. So in the case of browsing behavior based system, browsing based search system, you should provide an interface. That is for sure. You should provide a lot of control to the user, because user is not having any idea about the possible queries at any point of time. So that's why you should provide some sort of control, some sort of mechanisms through which user can directly operate on the data. So you can provide like in the case of e-retail platforms like Flipkart or Amazon, there are various facets has been given there, so that user can directly operate on these data objects. He should not be compelled to provide a query, right? So because both hints are unknown here, so if you provide control to the user to operate on the data, operate on the information object, the problem of balancing results, getting into the results will be partially resolved. There is a lesser load on the system side, because it will be partially taken care by the GUI part itself, right? So this is the tendency which we should be having while designing a search system. Because for a search system, user presence, user responses are the most critical ones to decide the overall performance. So that's why you should be precisely or carefully designing these 2 aspects of a search system. Now with this, let's have a view on the search process, which is basically the thought of today's lecture. Now I need you to take few moments to see into this, and we will again continue the discussion, right? So let's have a brief view on the search process, how different elements are placed in the search process, and what is the role of the transitions, and why we are having different AR, PR, and SR things. What are these things? What is their relevance? What is their importance in this entire search process? So you can take 1 or 2 minutes to see. Any question if you have, just raise the question, and then we can start discussing. Any question till now? Any question?
No, sir.
No, sir. Okay. So no is the most appropriate answer we can have. Okay. So do you familiar with all these notions which has been shown here? So in the right side, if you see in the legend part, you can see IR he shows the information retrieval system, or it could be any such system. W indicates the search task situation. So suppose I'm giving you assignment. Suppose that could be one of the work, right? Or maybe if you are having a question for your information need or your knowledge need, that could be W, right? So at any point of time, if you have something for which you need to engage a search or to start a search, that could be reflected as W. Now, CW is what it is saying as a cognitive perception of W. So cognitive perception always related to with respect to your understanding, your current knowledge. So if I give an assignment to each and every student today, different assignments to these 26 or 27 students today, naturally I will be having these assignments in the form of statements, right? So you need to write like, what is the information cascade? Can you find out? What is the information diffusion? Can you find out? So if I write these statements to you for these 26 or 27 students today, these statements will be basically maybe familiar to you in some way at some level, right? So if you are aware, if you are familiar about these statements, these assignment statements, you will start developing, some sort of conceptual understanding about the statement. So whatever assignment I give to you, you will start discussing. After reading the statement, you will start developing some conceptual, kind of gain or kind of clusters, kind of state, right? So that's what we are saying is a perception. So whatever knowledge you have with you right now, you will start developing some perception around this question, right? That's what we are saying is a CW, which is cognitive perception about your work, current assignment, current question, current need, right? Now, what we are saying as a SR, we are having SR, AR, PR, situational relevance, algos relevance, and pertinent relevance. Then there is a term called information need, N, right? So information need is again a kind of transformed version of W or CW, right? So that's why we have said N, information needs and its versions. Query, query is something with related to the system's availability. Like in the case of Google, you submit a query. Like in the case of Google search on image, you search different type of query. In the case of Google Earth also, you submit some query. In the case of different platforms. So query here is basically a reference of some sort of structured representation of your information needs, right? And naturally, after having some query, you will get some sort of results basically, right? O is the representation of retrieved information object, right? So retrieved means for a specific query, whatever query is basically matching with those information objects will be retrieved. So suppose in your repository or in your corpus or maybe in your database or data set, you have kept 100 number of PDF files of research articles, 100 number of images, 100 number of videos. So whatever query will be submitted, few will be matching. Naturally, there will be some matching mechanism. There will be some approach to estimate the matching also. That's what it is called relevance in the case of information retrieval. In the case of data retrieval, it was not relevance, it was matching, right? Because it is data retrieval is based on deterministic nature. In the case of information retrieval, it is probabilistic. So that's why it is based on relevance mechanism. So between query and result or set of objects, there is a mechanism of relevance estimation based on which the matching or maybe relevant results will be retrieved. That's what is the philosophy. Now, what we are saying after that, there is relevance assessment and there is a reinterpretation, there is a transformation. So there are some representation which we have used in this diagram, and this diagram as well as the previous one, it is coming from the published work actually. So this is what, and this is how we have interpreted as a search task. I mean, this is not a new phenomena we are proposing, but it is available in some sort of theoretical representation. So we have captured this from theoretical to a graphical notation we have given to a search process. Now let's start. So by this, in the outer space, you can see it is the real world. So this outer rectangle or outer square, whatever you shape assume, it is the real world where we exist, where this IL system exists, where this W exists. So only three entities are there in the first view, if you see. So W is the task which is coming in the real world by some individual to you, right? There is the IL system which exists in the real life, real world. There is this cognitive space of yours. So this ellipse or elliptical space where we have written as a user cognitive space. It may be your cognitive space. You may be your sometimes it may be referred as your mind. So this does not capture that mind part or your brain part. This reflects your cognitive space. Cognitive space means where these logical decisions are being made in your brain by using your current knowledge. I'm saying logical decisions made by using the current knowledge state of yours, right? So this reflects the entire part of logical decision making, then utilization of knowledge space. So you can correlate with this, that DFD diagram, I hope you can recall. So in the DFD also we have processes, then in between process there is an information flow. In some processes it requires some support from the data set or data store. If you are familiar with that part, you can easily correlate. So in the user cognitive space, we assume that kind of mechanism there. In the cognitive space, there are some logical decisions have been made based on or by utilizing the current knowledge state, current experience about the search task, right? Now, so how it basically starts. So suppose in the real world space, there is a task given to you. There is assignment given to you, which is in the form of W, right? So you naturally perceive that work, assignment which is given to you. Now, after reading this statement, reading to this work, reading to this maybe any hypothesis or maybe any fact, and so suppose you are planning to go to a particular trip or maybe particular for interview you are preparing for. So in that case, this task will be naturally coming from the real world, right? So once you get into this task, naturally you immediately start developing some sort of cognitive perception, right? So in the very first instance, you develop CW1. That's what is the cognitive perception in the beginning. So after getting familiarity with the task, with the work at your hand, you immediately start building CW. First perception, first conception about the work, question, assignment, situation, anything you assume in the real world. So if you develop CW, so you collect or recollect each and everything which you have with you, knowledge or maybe experience. In some cases, for some tasks, you have some experience. In some cases, you have only knowledge, no experience, right? So in the case of both knowledge as well as experience related to the current task, you start building with CW. And it is because in the first instance, we are referring as a CW1. Now, after getting into CW1, now because you know that you have this sensibility that eventually I have to interact, I have to look for the answers for this CW1 or W with a search system by interacting with the search system. Now, your cognitive ability gives you an idea that, okay, you have to start identifying or appropriately formalizing, some sort of query, some sort of request, some sort of needs. That's what we are saying. So needs are, which is represented here. Needs are something which is the transformed version of CW, more structured version of CW, more organized, more formulated version of CW, but it is still in your cognitive space. It is still within the boundary of your brain or maybe your cognitive boundaries, right? So here N is just a transformation, just basically, you can say the formulated version of CW. Now, how we are going to reflect this N? So whatever N you have developed, like suppose you are given assignment to find out the reasons or maybe different techniques for CW, you will be looking for some sort of terms which is related to information, or maybe which is related to diffusion, or maybe related to basically different factors related to information, something like that, right? So you will be having lot many keywords, lot many questions, lot many terms, anything at the stage of N related to CW. Right now, eventually one of it should be written to the search system, written onto the search system, maybe in the form of Q. Right? So you will be typing one or two keywords into the search system boundary. So that's what we are referring as a query in the real life. Right? And this is how we are interacting. So whenever you go to search system, whenever you go to any platform where search is given as an option, so these are the spaces, these are the things which are happening in our mind, and the reflection of all these states will be reflected in the form of query term Q. So once you submit Q, you know what will be the possible steps. So after getting into query will be submitted, and the submitted query will be utilized to generate or to spot, to outline, to identify, to retrieve, to search these possible relevant results, relevant objects from the storage. And there is system place here which will be responsible for estimating the relevance, generating the results to the user. Right? So in the very first, on the very basic level, the relevance which is used, it is called algorithmic relevance. Algo relevant, or maybe any equation. So when I say algorithmic relevance, AR, here you can say A. So AR or A is a mechanism to simply match, to simply have some relevance estimation based on the user typed query with information objects feature. So like one of the mechanism, if you type a keyword, I can get some of the documents where this keyword is appearing. So you can take out the query term and simply find its presence, its existence within the document, something like that. So you can have some algorithm, some mechanism, some equation to find out the relevance of user query term in these information objects. Right? So you must have heard about TF-IDF mechanism. There are some similarity mechanisms available which directly takes the user query and find out the relevance of that keyword into the document set. So all those mechanisms are called AR, algorithmic based relevance mechanism. Right? So that's one. So initially when we submit a query, system will generate some results, some information objects will be returned, given to you. Now, after reading these results, you will have naturally, so after getting the results, you will observe them, and after reading to these results, your CW will be revised. W will be same because W is the task, it is the assignment given to you. Now, whatever change we are observing after reading to the first set of results, after the results, after reading the results of first query, Q1 basically now. So after reading the results of, after reading the R1, result set R1, you will gain some knowledge, you will gain some idea, you will have some idea about the, results with the CW1, with the query one, with the N1, something like that. Now, in the very next moment, after reading the search results, your CW will become CW2. Your cognitive perception about the work is now evolved, is now changed. So based on this evolution on CW, you will now again formalize an new need, which is N2, and will go to perform Q2, query Q2, and we'll get R2, and then we'll have CW3, then CW4, something like that. So based on your interpretation, based on your intuition, you can continue like that. So if you can have interaction with the system 10 times, I assume that there will be 10 queries. 10 or 11 CW will be there, right? So eventually after 10 queries, after 10 or 11 CW evolutions, you will have sufficient amount of details, sufficient amount of knowledge with you for a given W. That's what is the evolution process within your community space. And in the real life, we are evolving on instance basis. On each second, we are evolving. When we interact with information, when we interact with data, we gain something from it and we evolve. Our knowledge state evolves continuously. That's why. And it reflects on the query, nature of query, selection of keywords, even your statements, even your interactions, even your any comprehension ability. Even if you learn a lot of things, you will become more confident, something like that. So if you correlate with this, the real life situations where some says if you read 1 year, if you prepare for examination, you will get a lot of knowledge gained into it. And this knowledge gain also reflects on your behavior, right? And this is happening because these things are accumulated in your cognitive space, where we are building our logical decisions by utilizing the knowledge which we have related to anything, right? Now, after having this evolution in the CW and their reflection on needs, reflection on queries, and getting some results, getting revised results, what are these two elements existing? P and SR, P or SR, right? Pertinent relevance factor and situation relevance factor. So till the time when we have not discussed HCI, role of human computer interactions. So before the evolution of HCI, we have never thought about these two relevance factors, pertinent and SR, pertinent relevance and SR relevance. So it was perfectly fine. We have different algorithms to calculate the relevance. So there are various mechanisms has been designed through which you can capture the algorithmic relevance to get precise results for user query. Now, with the evolution of HCI, it has been assumed that whatever we are getting as a query, that is not sufficient to basically help the search system to get more precise results, right? So some of the researchers assume that if we could able to model, if you could provide some algorithm, some equations, some set of mechanism through which we can capture the evolutions in the need level, evolutions at the needs level. And needs are what? Needs are basically happening, changes on the needs are happening well within the cognitive space. So how to capture that reflection, that evolution? So if you could design some of the mechanism, like in the case of AR, we have designed what? TF-IDF based mechanism, similarity based mechanism. There are various mechanisms to model this relevance. So there are various mechanisms has been proposed nowadays, which says that the pertinent relevance, the changes on the information needs, or maybe some view of it has been captured to help the IR system to get the result. Now, if you are able to model AR you can model because there are various mechanisms available. Now, if you could able to model or capture changes in the needs, you can have two alternate. Now you can have two mechanisms, AR and PR, to capture the user need, capture the user request, right? So you will get better results, more results which are specific, centric, or maybe matching, or maybe relevant to the user's need, right? So some people assume that if you could capture the, or you could provide some sort of mechanism to the user through which he can reflect his needs, like along with the query, if you provide some mechanism to click on some result, to review it, to feedback it, to tag it. So if you provide some alternate mechanism along with the query, by that you can capture this pertinent relevance. There are some aspects of information needs which will be reflected by these informal, unstructured mechanisms, right? So that's why in the study class only we have talked about this review element in the search process. So this pertinent relevance is something for which there are various efforts, there are various research works has been introduced to capture some element of needs. There are many elements, there are many aspects of need factor, and these all are informal, right? So this nowadays we are having some systems or some such systems or such platform where this evolution on need has been captured. So now they are having two mechanisms to capture the relevance, two mechanisms to estimate the relevance. One is based on algo relevance, one is based on pertinent relevance. So both are utilized to get the most user-centric results, something like that. But there is a third aspect which is almost impossible to be captured, and that is it possible to capture the evolutions in the cognitive perception of work, CW evolutions, right? So if you are able to capture, if your system, if your algorithm is able to capture these evolutions in CW, maybe by utilizing some of its effect, some of its aspect which are reflected in our behaviors, right? Because this is something which is stored or kept or located in the utmost or maybe innermost portion of the human cognitive space. So capturing it is the most difficult task, right? Right, that's what we are trying to get into the future. So this if you are able to design something which reflects, which captures the SR, the situational relevance, and model it and utilize it for getting the relevant result, then your system will be for the future need, right? And that's what the space also. So we have talked about partially the wisdom part in the very first discussion, and that's why I'm saying there is no system available which captures, which models this wisdom part. So this evolution in cognitive perception CW1 to CWN is the evolution which reflects the gain in knowledge. Sometimes it is called, so gain in knowledge is often called as a wisdom, right? So if you are processing, if you are updating your knowledge state, it is basically generating the wisdom state in your mind. So modeling the changes on cognitive perception by using some mechanism, some sort of tool, some sort of formula, some sort of equation is the toughest or maybe complex task till now with respect to IR systems, right? So there is no system available which captures till now SR part, but this is something important which we will be having in future. Maybe down the line 10 or 15 years we will have some sort of systems which captures this evolution on CW on the behalf of user, right? So that's it for today's discussion. I hope things are now related, and now we are getting into the discussion which are planned in the coming week. So next week we will be getting into the different elements of a search system, not IR system, search system, right? So any question you have, I will be posting this reference notes along with few other questions also. So I will be posting few questions. Perceptions. Any question from your side till now?